Hello friends, welcome back to my YouTube channel. Hope you all are doing well. So this is me Rameen Ali, and today I am back with another video. In this video we will learn this 8.2, the size and direction of a force. In previous video we will learn about this 8.1, the effects of a force. Okay, from 136 page 136 to 144 pages. Today we are learning page number 141. Okay, let's read it. Force is size of a force. Forces can be weak or strong. The forces of earthquakes The forces of earthquakes and cyclones are strong enough to cause great damage. In the laboratory, the size of a force can be measured by a force meter or spring balance in the unit Newton. Okay, in this paragraph, they will say that force is weak or strong. It's not like it's too weak and it's too strong. It's weak and strong. The force of earthquake and cyclones are too strong, so they can do a lot of things bad and cause great damage to the buildings that are in constructed. In the laboratory, the size of force, when you go in the library, you will see that the size of a force can be measured by spring balance or force meter. Here is a compression spring balance and here is a extension spring balance. In compression spring balance, there is a tray on this and there is a meter. So we can put it's an apple and it's of 100 gram, mean 1 Newton. We can put an apple on this, so here will be shown whatever it is. So we put an apple, it's push the tray. Okay, but same goes here. No, it's an extension spring balance. When we like a shopping bag, we can buy some fruits, vegetable in a shopping bag. Here's a hook, here is a hook, there here is a piece of wood or whatever you say. It's a piece of wood hanging on extension spring balance. Why it's extend? Because when we hang something over here, here is a spring inside it over here, so the spring extends like this. So it pulls the thing that we hang, it pulls the spring down, and in compression the thing pulls or push it's like this. Here is a tray, I can put here like this, so it can do like this. See, okay, that way it compresses when we put anything on this tree, and it extends when we hang anything over here on the hook of the extension spring balance. That's why this is called a compression spring balance and this is called an extension spring balance. Okay, come towards the next page number 142. Okay, a spring stretches when it pulls and compresses when it is pushed. The larger the force, the more the spring is stretched or compressed. For this reason, springs are used to measure force. A spring stretches when it is pulled. It stretches when it's pulled, like this. Here you will learn like this. And the larger the force, the more spring is stretched or compressed. For this reason, springs are used to measure the force. Now, here's the try it out. It's about 1 Newton, extension 2, 3 Newton, 4. Force is measured in Newton unit. Newton. 1 Newton is equal 100 gram. 1 Newton is equal 100 gram. 2 Newton is equal to 200 grams. Same goes here. 300 gram, 3 Newton, 400 gram, 4 Newton, 500 gram, 5 Newton. Okay, now come towards the next page. Direction of a force. Now we can learn the direction of a force. Look at the diagram of an aeroplane flying in the air below. We don't know that it's taking takeoff, it's landing, it's in the moving in the air, but it's now they will say the look at the diagram of an aeroplane flying in the air. So it means that it's flying aeroplane. Okay, so there are some arrows force from which we see. Okay, these are some forces acting on an aeroplane. Let's read the text. The arrows show 4 different forces acting on the aeroplane. The direction of each force is indicated by the arrowhead and size of each force by the length of the arrow. Okay, these 4 arrows, thrust, weight, lift and drag, shows forces acting on this aeroplane. The direction of each force is indicated by this arrowhead. Okay, this arrow. Look, the comparison between lift and weight, thrust and drag. Drag arrow is smaller than the thrust and lift is bigger than this arrow of weight. Okay, so these are indicated by their arrows. From the diagram we can see that more than one force can act on an object. The lift acts upward in the opposition direction of the weight of the aeroplane, which pulls it downwards. The drag, air resistant, acts it in the opposite direction of the thrust, which moves the aeroplane forward. That what will happen to the aeroplane if the lift is 0? How does the drag affect the forward motion of the aeroplane? In this paragraph they will tell that we can see that more than one force are acting on the aeroplane. There are more than one, okay, acting on an aeroplane. The lift, this is the lift act. Look at there, it's the arrow of the lift. Okay, it's bigger than this weight one. The lift acts upward, it's acting the upward and its weight downwards. If the weight is more than the lift, so aeroplane weight will go downwards, not upwards. Okay, thrust mean drag mean air resistance, and thrust we can say that up thrust force. Okay, so if the thrust goes there and drag here, drag is smaller than the thrust one. The drag acts in the opposite direction of the thrust. Opposite mean over here on the right side and thrust on the left side, which can move the aeroplane forward. Okay, if drag is more, so aeroplane cannot move here forward. Okay, so now learn the key points. The size of the force can be measured using a force meter or spring balance. Forces are measured in newtons. A force can represent the length by an arrow. The length of the arrow represents the size of the force, and the arrowhead indicates its direction. Several forces can act on an object. Example: different forces act on an aeroplane flying in the air. So here's the question. Here, how size of force can be measured? The size of a force can be measured. Here I am written how size of force can be measured. how force are measured for some in Newton in which unit, okay, and how force is represented. So it's yellow one is the answer, okay. So in the next video we can learn this 8.3 magnetic force. Let's recall all 8.2 that we learned the size and the direction of a force. Okay, so we can learn 8.2 this the size and force of direction. A size of a force can be measured with a force meter or a spring balance. The unit of force is Newton. Symbol is N. Okay, 1 Newton is equal to 100 gram, 2 Newton, 200, 300, 4 Newton, 400. Okay, and compression spring balance compress, that's why it's called compression spring. And when the spring balance expanded, that's why it's called expansion spring balance. Here's I'm drawing I have drawn an aeroplane. It's not like look like an aeroplane, but imagine that it's an aeroplane. So we can learn the direction of a force. This arrow indicates left. This arrow indicates weight. This arrow indicates the drag force, and this the thrust force. Okay, lift force is more than the weight, and thrust force is more than the drag force. So okay, it's the recap that we will learn. Okay, so meet you in the next video. If you are new at my channel, so subscribe my channel and hit the bell icon. Meet you in the next video. Allah Hafiz.